Welcome to this video on the hydration of alkenes. So hydration of alkenes. When you hear the word hydration, what should you think? Well, you should think about water. And in these reactions, we also use sulfuric acid, so H2SO4, and this sulfuric acid is aqueous because we are in water. So some important things to know before we do the example is to know where our molecules or where our atoms are going and what's doing what. So our H2SO4, so H2SO4 is our proton donor. Our water gives us our alcohol. And this alcohol will attach on the most substituted carbon. So alcohol will be on the most substituted carbon. So this is also where our carbocation will be. So we also get a carbocation. And sometimes we get carbocation rearrangements. So sometimes we get carbocation rearrangements. Okay, so now let's go through the mechanism so things will make a lot more sense. So I'm just going to take a random alkene, such as, let me fix that, such as this guy right here. So the first thing that's going to happen is we are going to protonate it. So let me take our acid, which was sulfuric acid, HOSOH, double bond O, double bond O. So this is sulfuric acid. So first, we protonate it, shift these electrons back onto that oxygen to give us something like this. Notice our plus is on the most substituted carbon because of hyperconjugation, and we want that positive carbocation to be more stable on a tertiary position. So where did our hydrogen attach? Well, it attached right here on this carbon. So remember there were two hydrogens here in the beginning, and now we have three hydrogens. So what happened? We protonated the least substituted side. Okay, so first protonate least substituted side. And this carbon right here had 4 bonds originally, so we had 1, 2, 3, 4, and now we only have 1, 2, 3, so that gives us a carbocation. Okay, so I'm going to redraw our molecule with the carbocation. I'm not going to draw these hydrogens out. But anyways, what's our next step? Well, we're going to use our water. So HOH. Our oxygen will attack that carbocation to give us something that looks like this, where our oxygen has 2 hydrogens to it and then has a positive formal charge on that oxygen. So the final step is to get rid of one of these hydrogens, and we can do that by using another molecule of water. So let me draw these hydrogens out, give that a positive formal charge on the oxygen, use another water molecule to come up and attack that proton, shift these electrons back onto that oxygen to give us our final product of a tertiary alcohol. So this is the mechanism for the hydration of alkenes. This is our final product. I hope this video made sense. If you have any questions, please feel free to leave a comment down below, and thank you for watching.